Good day, everyone! Today we will be discussing about other sequences. In the previous lessons that we had, you were able to learn about the two kinds of sequences, which are the arithmetic sequence and geometric sequence. This time, let's talk about other sequences. There are two other sequences that we are going to focus on today. Before discussing thoroughly the other type of sequences, let's have first our goal for today. What is our goal for today? Our goal for today is to illustrate other sequences like harmonic sequence and Fibonacci sequence. These are the two other sequences that we have to focus on to today. Okay, so let's start with the first sequence, which is harmonic sequence. Now, what is harmonic sequence? Harmonic sequence is a sequence whose terms are the reciprocal of the terms of an arithmetic sequence. Okay, you have already learned about arithmetic sequence, and you already know that arithmetic sequence is a sequence whose terms are obtained by adding a constant amount, which is what we call the common difference. Since harmonic sequence is the reciprocal of the arithmetic sequence, so getting the reciprocal of the formula of an arithmetic sequence, so therefore the formula of harmonic sequence is 1 over a sub 1 plus quantity n minus 1 d, where a sub 1 is the first term of an arithmetic sequence, n is the number of terms, and d is the common difference, which is your arithmetic sequence. Okay, when we say reciprocal, how do we obtain or how do we get reciprocal of a number? So let's have these examples. Supposedly we have 1/2. What is the reciprocal of 1/2? That is 2 over 1. We will just have to flip it, not literally, but the denominator will become the numerator. The numerator will become the denominator. So the reciprocal of 1/2 is 2 over 1, or simply 2, because 2 divided by 1 is 2. Likewise, the reciprocal of 5/6 is equal to 6 over 5, and negative 17 over 3 is negative 3 over 17. Okay? You cannot change the sign, as the sign is as is. Okay? So that is what reciprocal is. Now, you have learned already what the harmonic sequence is. Let's go. Okay, so we have here, let's try to identify whether the given sequence is harmonic or not. How do we know that the sequence is harmonic or not? Okay, supposedly this sequence, 1 over 11, 1 over 14, 1 over 17, 1 over 20, and so on and so forth. So, being 1 over 11 the first term, 1 over 14 the second term, and so on and so forth. Now, how do we determine if the sequence is harmonic or not? So, let's follow these steps. Okay, step 1, reciprocals. You have to get the reciprocals of the given sequence. So, you already learned how to get the reciprocal of a number. Therefore, the reciprocal of 1 over 11 is 11 over 1, or simply 11. 1 over 14 is 14 over 1, or 14. 1 over 17 equals 17 over 1, and so on and so forth. So the reciprocals of that given sequence is 11, 14, 17, 20, and so on and so forth. Okay? Now, let's go to step 2. We will determine if the given sequence, this one with arrow, is an arithmetic sequence. Okay? Again, after getting the reciprocals, we are going to determine if the given sequence is arithmetic sequence. How do we do that? Apply the formula in determining if the sequence is arithmetic by getting the common difference. How do we do that? We are going to subtract 14 and 11. What is 14 minus 11? That is 3. Next, 17 minus 14, that is 3. 20 minus 17, that is 3. Now, you have noticed here that all the differences are common. The same, which is 3. So what can you say about the sequence 11, 14, 17, and 20? Therefore, that sequence 11, 14, 17, 20 is an arithmetic sequence with a common difference of 3. So, in step 3 is your conclusion. Since the reciprocal is an arithmetic sequence with a common difference of 3, therefore, you can say that the given sequence 1 over 11, 1 over 14, 1 over 17, and 1 over 20 is a harmonic sequence. Another example here, let's have example number 2. Identify whether the given sequence is harmonic or not. Let's try the sequence. 1, 1/2, 1/4, 1/8, and so on and so forth. Again, let's have it step by step. Step 1, we have get the reciprocals. Reciprocal of 1 is 1. Reciprocal of 1/2 is 2. Reciprocal of 1/4 is 4. Reciprocal of 1/8 is 8, and so on and so forth. So you have now your reciprocals, and after that, go to step 2. Again, let's determine if that sequence 1, 2, 4, 8 is arithmetic. Now let's check. How do we check if it is arithmetic? We are going to have the common difference. In getting the common difference, we will subtract the current term to the previous term. So 2 minus 1, that is 1. 4 minus 2, that is equal to 2. 8 minus 4, that is equal to 4. Now, you've noticed here that 1, 2, 4, which are the results, are not common. So you can say that since the differences are not the same, the differences are 1, 2, and 4, they're not the same, you can conclude that 1, 1/2, 1/4, 1/8, and so on is not harmonic sequence. Again, why not harmonic sequence? Because when you get the reciprocal of the given sequence, if that reciprocal sequence is not an arithmetic sequence, therefore the given sequence is not harmonic sequence. Let's try number 3 example. Insert 5 harmonic means between 1/4 and 1 over 22. Now let's illustrate this one. So this is what it looks like. We have 1/4, then 5 harmonic means in between the two given, 1/4 and 1 over 22. Okay, now in determining the missing terms or the harmonic means, we still need to get first the reciprocals of the given sequence. What is the reciprocal of 1/4? That is 4. The reciprocal of 1 over 22, that is 22. 4 here is your a sub 1. Unknowns, which are a sub 2, a sub 3, a sub 4, a sub 5, and a sub 6, while 22 is a sub 7. Now, since the given 1/4 and 1 over 22 is already a harmonic sequence, therefore, these reciprocals 4 and so on, blank, 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 blank to 22 is already an arithmetic sequence, right? Okay, now how do we solve the missing term of arithmetic sequence? Going back in our discussion about arithmetic sequence or arithmetic means, in order to get these missing terms, a sub 2, a sub 3, a sub 4, a sub 5, a sub 6, you need to have the common difference. Because if you have the common difference, you can get already the second term by adding that common difference to 4. Right? So we are going to solve the common difference. So we have our step 2, find the common difference. How do we do that? We're going to apply the formula of arithmetic sequence. Again, this is the formula of arithmetic sequence. A sub n equals a sub 1 plus quantity n minus 1 d. So, what is a sub n here? A sub n here is your last term, which is, what is your last term? Which is 22. So 22 equals, your a sub 1 here is the first term, which is 4. N here is 7. Why 7? Because there are 7 terms from 4 to 22. Times d. Your d is unknown because you are going to determine the common difference, which is your d. After that, 22 equals 4, copy 4 plus 7 minus 1 is 6. 6 times d is 6d. So, transpose 4 to other side. That becomes 22 minus 4, which is equal to 6d. 22 minus 4, which is 18, equals 6d. Then, divide by 6 both sides. Therefore, your d is equal to 3. The common difference here is 3. So, you can now determine the missing terms. So, by adding 3 to 4, that becomes 7. 7 plus 3, that is 10. 10 plus 3, that is 13. 13 plus 3, that is 16. 16 plus 3, that is 19. And 19 plus 3, that is 22. So, this is now the arithmetic sequence that starts from 4 and ends with 22. Okay. So, what is then now the final answer? What are the missing or the 5 harmonic means between 1/4 and 1/22? So, conclusion, we will just get, and the reciprocal of 7 is 1/7. So, reciprocal of 10 is 1/10. Reciprocal of 13 is 1/13. Reciprocal of 16 is 1/16. Reciprocal of 19 is now 19. So, the 5 harmonic means are 1/7, 1/10, 1/13, 1/16, and 1/19. Okay, let's proceed to the next sequence, which is Fibonacci sequence. What is a Fibonacci sequence? A Fibonacci sequence is the series of numbers or sequence of numbers that starts with 1, 2, 3, 5, 7, 13, 21, 34, and so on. This is the only Fibonacci sequence. How do we obtain the next number of our Fibonacci sequence? So to obtain the next number of Fibonacci sequence, we will just add up the 2 numbers before it. Example, the third term, which is 2. How do we get 2? By adding 1 plus 1, the previous 2 terms, which is equal to 2. So how do we get 3 here? So by adding the previous 2 terms, 1 and 2, which is equal to 3. 13 is obtained from adding 5 and 8. That's it, and so on and so forth. So that is Fibonacci sequence that starts with 1, next 1, 2, 3, 5, 8, 13, 21, and so on and so forth. Okay? Okay, now let's proceed to getting the rule or formula of a Fibonacci sequence. Now, let's try to look at this table. And here is the terms. First term, second term, third term, fourth term, and so on and so forth. F of n here are the terms of the Fibonacci sequence. 1 is the first term, 1 is the second term, 2 is the third term, 3 is the fourth term, 5 is the fifth term, 8 is the sixth term, 13 is the seventh term, and so on and so forth. Okay, so what is then the formula of, or the rule of Fibonacci sequence? Okay, before that, let's take this example here. The 8th term, which is 21, is obtained by adding the 7th term and the 6th term. So 8 plus 13 is 21. So what is then now the rule or the formula of Fibonacci sequence, where f of n is the nth term, f of n minus 1 is the previous term, and f of n minus 2 is the term before that. Okay, so in getting here, in getting the 15th term, we will add the 14th term and the 13th term. In getting the 20th term, we're going to add the 19th term and the 18th term. This is how you get the Fibonacci sequence. Now, it's hard for us to solve the nth term of Fibonacci sequence if we are going to use the rule or the formula that I mentioned a while ago. Supposedly, I will say find the 60th term of the Fibonacci sequence. So you have to know first the 58th term and 59th term to get the 60th term, which takes time, right? So what we are going to do is, let's have this another formula, which is the golden ratio, where phi is equal to approximately 1.618034, and your n is your nth term. So in solving golden ratio, you need to have a calculator, so it's easy for you to find the Fibonacci sequence. Now, what is this golden ratio formula? This golden ratio formula will help you find the nth term of Fibonacci sequence. Let's try this example. What is the 6th term of Fibonacci sequence, or the f of 6? So let's have the solution. Let's use the golden ratio formula. So in golden ratio formula, you only need n, which is 6, and the phi, which is already constant, which is 1.618034. So just use the formula, substitute f of 6, n is 6, equals, your phi is 1.618034 to the power n, which is 6, minus quantity 1 minus 1.618034 to the power 6, all over square root of 5. Now, I want you to use your calculator for this because it's easy for you to solve if you have scientific calculator. Okay, if you're going to key in these informations in the calculator, you can have an answer of 8.000033 or 8. You're going to round off it into a whole number. Again, into a whole number. So if we're going to round off it into a whole number, 8.000033, that becomes 8. So the 6th term is 8. Let's check. In that table, we have n. What is the 6th term here? So you can see here the 6th term, which is 8. Okay, let's try this next example. Find f of 10, or the 10th term of the Fibonacci sequence. N here is 10. Phi is 1.618034. So using the golden ratio formula, substitute it. N is 10. Phi is 1.618034. If you're going to simplify this one, f of 10 is equal to 55. Again, 55 is already rounded off, so we can say that the 10th term is 55. Let's try to check. There you go. The 10th term of the Fibonacci sequence is 55.